Number 12, for any element be able to draw, to write or draw, depending upon what you're being asked to do, the orbital diagram, the ground state configuration, the noble gas, or the electron dot. And again, you will have a helping hand. The last page of your test, you'll be able to tear off, and it'll have those examples for lithium to remind you ground states with the exponents, orbital diagrams, the boxes, noble gases when you shorten up the ground state by using a noble gas. And the dot diagram is just that, it's just dots. So if you're going to do the orbital diagram, if you're going to do it for any element, what's the first thing you always have to know? How many electrons? Except for the dot structure, then you just need to know valence electrons, but you still have to know something about its electrons. So if you look at chlorine, how many electrons does chlorine have? 17, because that's the big number. Don't get confused and try taking the atomic mass, because it's got a decimal, and that should be your hint that that's the wrong number, because you can't have part of an electron. You can't have 0.898 electrons. So then when you see that, go, oh, right, number up on top. So I have 17 electrons, so now I have to draw the boxes. So the first box on my chart says 1s. And if there's only one box, 2 electrons. 15 left. Second box says it's a 2s. Still just one box. So 2 more electrons. Down to 13. Looked like a lot of you could do this on the partner or the homework quiz today. And then I get to 2p. Everybody know where I'm getting these from? On the back of your periodic table? That can hold 6. I've still got 13 left, so I can go ahead and put 6 in here. So now there's 7 left. So then I could go to the 3s, and it can hold 2. And then the 3p, this is where you have to be careful. It could hold 6, but I only have 5 left. So now I should put 1 in each and then start pairing them up. So I make sure I follow the bus rule. Okay, that's the slowest one to do because it gives you the most information. It shows that all 3 rules are being obeyed. So if it's going to do the ground state configuration, this one gets quicker because now I don't have to draw boxes. But copper, that one's kind of big. What's its atomic number? Copper, Cu? 29, that's right. So copper's 29. So I do the same thing. I find on my chart 1s is the first one, so it's got 2. So I'm at 27. 2s is next. It only gets 2. I got some wrinkles in my board that make it look like I'm shaky or something. So I put 2 in there. Then 2p, which can hold 6. 3s, just 2. So I'm down to 17. 3p can hold how many? 6. So now I'm down to 11. And then 4s sneaks in before the 3d, so this just takes 2. And then 3d could hold 10 of them. So the last 9 go there. You don't have to fill up the last one. In fact, most elements won't fill up the last orbital it's on. So my last 9 go there. So that's my electron configuration. Noble gas configuration, if you can't do this without doing the ground state first, it's not a good shortcut. So noble gas, the idea is that if you look at lead, what family or what period is lead in? It's PB. It's got a weird symbol. Is it 82, I think? 83, 84, 82? So it's PB. It's number 82. And what period is it in? So it's in row 6 or period 6. So what that tells me is that the first 5 rows are filled up. The first 5 energy levels are full. So 5 energy levels are full. And if I look at the periodic table, what's the element at the very end of period 5? If you go all the way to the right on period 5, what is it? Xe? Xe. Not, yeah, Xe is all the way at the end, which is how many electrons in Xe? So I get to start out with Xe, because what that's saying is 54 electrons, just like Xe. It's like saying ditto. I don't have to write out how all the electrons fit in Xe, because those 5 are full and we don't care about them. They're not going to be part of the reaction. So then if I just took care of 54 of them, I only have 28 left that I have to worry about. And what row did you say we're in? 6? So if I look on my chart, what's the first orbital to fill up in the 6th energy level? If you come up from the bottom, what's the first 6 you see? That's not 6. 6s is the first 6 you see. And how many can fit in an s orbital? 2. So now I'm down to 26. So then you look at what gets filled up next. Yeah, it goes all the way back to 4f. How many can an f hold? 14, because there's 7 boxes. So that takes care of a bunch of them. Now I'm down to 12. So then after 4f, then it goes to 5d. So the order seems kind of goofy, but who cares? All you're doing is looking at the chart. So how many can 5d hold? 10. So now I only have 2 left. So 6p gets the last 2. Okay. So noble gas configurations aren't that hard once you understand the trick. That whatever period it's in, you go one period above, one row above, and that's full. So go all the way to the right and see how many electrons that takes care of. And then you use the noble gas to say, yep, 54 electrons, handled, don't need them. Yeah. Because I looked at row 6 is where 82 is at, where lead is at. So I looked at the end of row 5 to see what would 5 full rows look like. It would look like Xe. It's always whatever's in the far right. So 81, I'd still use Xe, but then when I put them in, I'd only have 6p1 because I'd have one less electron. Let me do the dot structure, and I'll do another noble gas one. Okay? Okay. So the electron dot structure for fluorine, if you find fluorine, what group or family is fluorine in? Yeah, it's in family 17. So group 17 means 7 valence electrons or 7 dots. So you put 1 on each side and then you start doubling them up. My board's off a little bit, so my dots look a little goofy, but you get the idea. So you follow the bus rule with the dots too. Put 1 dot on each side and then double them up where you need to. Let me see if I can get those a little cleaner. So 1, 2, 3, 4, 5, 6, 7. So one side is still missing a dot or an electron.